And the talk is not going to be about techniques, and at the same time it's going to be about techniques. So we're going to talk about data and about things we do at Rabobank, and we started not last year, but last year we started with BigML, but we started in 2008, 2009 with the things we do in our department, and I'm working for your information at the compliance department, and we do fraud, money laundering, terrorism financing, stuff like that. So the nitty-gritty stuff at bank. This is me. I work at Nyenrode University. I do some things with algorithms, robotics, and I know a lot about cybercrime and stuff like that. This is Rabobank. We do 10 million transactions a day, and from that 10 million transactions, we need to find something that's fraudulent or suspicious. We have a daily alert rate of about 100, and we have 5 till 25 are true. So statistically, this is a nightmare. So what we did in 2008, we capture a lot of them. Yeah? And of course, with fraud, it's an easy case. If somebody's been frauded, he calls the bank. That 50,000 euros to the Ukraine was not my intention. He will most certainly tell us. Money laundering is differently. Somebody who launders money will not call the bank. Yes, I happened to launder 1 million euros of money. He will not do that. So that's our task to find things. This is what we are facing on a daily basis. And since 2009, we just started with, we call it still AI, rule-based systems, a rule-based system that says, okay, if I have a scenario A, and that comes, and then we just flag it as a fraud. We stop we block the transaction, we block the card, we call the customer, stuff like that. We do it with rules, not with coding. So we started very early to be a non-coding environment, and we used fuzzy logic to do that. And very important, we started with an event-driven architecture. So at the start, we said, okay, we cannot do in databases. We cannot look back. We just have to do things on the spot when they happen. So we have, for the technicians under us, we have machinery that has 500 gig internal memory, and we store for every customer in memory profiles we reason about. Yeah, but that's all manual work, manual coded rules, manual coded models. And the first intervention I did was to separate IT from business. So this is the upper part is business and the lower part is IT. That is crucial. My role, even though my team has almost the most computer scientists in the bank, they're not a large team, but still. But we are placed in the business. We are a business department. We have IT teams that work for us on the infrastructure and the platforms, but we as a business control the logic and the models. Keep that in mind, because that's an important thing you need to know when you talk about how to implement things in a speedy, quick way. Because we found out that we need to respond very quickly to the situations that we come across. If there's a fraudster and there's a new fraud, we need to get in there at the moment it happens. So we created an infrastructure that we as a business make rules and models, and we can deploy them into production real time. With handmade models, and now also with BigML models. So we can really, as things happen, change our models and put them in production. And for a bank, that's not a sinecure, because it's all, it's scary, because you can break down the financial system and nobody can pay anymore, stuff like that. We worked with that. So we had business and IT split. So keep in mind this very important organizational aspect of making this work. And we did, in the last 2 years, I thought, okay, we're mixing up things. We're mixing up production issues with exploration issues, with research issues. We also have a team around me of a few PhD candidates that work on new machine learning models, or new concepts for for example, for explaining complex models or for doing difficult things with text. We have in the bank approximately 500 million documents about customers, and we want to know, is there any clue in those documents that point towards money laundering or illegal or suspicious behavior? We need to split something like production, exploration, and research. So our organization and our team is also split up in that part. I work a lot in exploration, and you see we have things there like rule-based, case-based, and machine learned. Those are in production, but they are also in exploration, and this continuous improvement, creating and finding out novel ideas and methods. So that's what we split. But we need to make sure that things that we do in research can be put into production as quick as possible. So the infrastructures and the structures we use are fairly the same. What did we use since 2008? Because we used Inform, that's a rule engine with in-memory database for our sub-second reasoning and actions. And we used the machine learning to help our staff to do some analysis. We used SPSS, SAS, VECA, R, and Python. But we thought that's not good enough for us. Just continue to something that looks like a platform, and we can use to not only do the machine learning stuff, but also be traceable and being able to tell to the customer and to a regulator what we did, how we did it, and how the model works and how it looks like. And for me, one selection criteria was that models should be explainable, or at least the process getting there should be very explainable and transparent, because I cannot have the situation that the regulator comes in with me and says, Jan, that model that you have there, does it work? I say, yeah, it worked. How did you create it? Now, I had an engineer 2 years ago, and he created a nice R thingy, and he downloaded for somewhere a very cool new algorithm, and he applied that, and it worked. But what it does, and by the way, the engineer left. So I'm stuck with something that I cannot explain, I cannot account for. I needed that. So since 2018, we work with RiskShield and BigML, and they are interconnected. So the models from BigML seamlessly go into my RiskShield real-time online detection system. And I thought of platforms, because I do not want single thingies in there. So I have a platform for a machine learned data lake. If you think on data lakes, every large organization talks about data lakes, but you need something specific for machine learning. You cannot do with a general data lake. I can talk to you about what the specifics are if you want later. We need something like machine learning, and we rebranded BigML to RaboML for the sake of. That works very fine. So you have a website this is Rabobank, raboml.rabobank.nl. So it's very cool. And we have something to put the models into production. Because we started off, we want something to get our models into production. And productionizing of the models is not one-time task. That is a continuous task. That is a task when a regulator comes in, there's something happening with money laundering with the Danske Bank. We need to do something to fix it or to see if something at risk at Rabobank. And we do a case and alert management, and from that we need feedback. So we want continuous feedback from our internal organization on what models do and what the outcome is. And we want to use that and reuse that to optimize our models. Even we just talked about anomaly detection, that you even want feedback on anomalies in there. Okay. This was our first idea about an Indonesia card fraud. And it's very impressive that out of the box, BigML comes with a very good score for us. We had 6,189 alerts in there. That means that somebody has to look at it and say, this is fraud, this is not fraud. Only 93 of them were actually fraud. So you see people do things repetitively and stuff like that. And BigML comes up with a nice ratio of only missing 2 frauds. That's not an issue for us. The larger issue is the number of false positives, and we reduced the false positives to, let's say, 300. We even got better than that. We reduced false positives to 0, but this was our first result out of that. And we can also, of course, you can use all kinds of things to augment the business rules we have, because we say business rules are still in place because we need the rules for things we already know. If we have knowledge, we can write a rule, we write a rule. If machine learning works better, we throw out the rule and we put in machine learning models. And these are the services we do. We are starting up with, we already do with rules, and we're just going to do with machine learning and augment with machine learning at the moment. So that ranges from know your customer, CDD, fraud, anti-money laundering, correspondent banking, terrorism finance, all cool and stuff. That's all the dark side of the bank where we are. It's a small piece where we work with villains and stuff like that. But we are in the digital transformation, and digital transformation for us means that we have to do more. The bank is sitting on tons of data. That's enormous. And the bank, silly enough, only starts to realize that it's a pot of gold in some sense. So, artificial intelligence, low-code, and cybersecurity. These are the trends for 2019. I looked them up for you, and happily, I'm in all but 3 of them. So and what we did in 2008, we just put BigML on-prem in our own data center. We have, as compliance, a small data center. That's a few racks in our large data center. We put in our own hardware to put BigML on, because we said, we want to be sure that we are not the first in the bank that go to the cloud and spill our privacy data or the investigations we do, because I want to do every investigation we do, and that ranges from customers that are kicked out of the bank because they behave badly, to employees, to specific cases. Everything you can imagine that could happen with criminality or cybercrime or internal crime is being handled by our department. And you know, I'm still not an IT guy. And I'm not a compliance guy, but I work at that department. And we started to experiment, because I said, we started in June, in August, September, we started to do round trips, and we started experimenting. And at this moment, I say to everybody in the bank, if you have a problem and you have a good data, and you have a data set, doesn't matter if it's good or not, come with me, and we make a model in half a day. So it's 4 hours, and we get around your problem, we get an idea of the solution, and we get you going. We did roadshows. So we did roadshows. We did not. The best friends I have within the bank are not residing in IT and not in data science, because they say, Jan, what you do with BigML, I lose my job. Really. I had a student, and she was from the university. She came to me, Jan, if you tell me that, I get scared, because I'm in the university 4 years, and you tell me that all these things I learned to do hard-coded with Python and R are not needed anymore. I said, no, yeah, a little bit true, a little bit not true. Your skills are necessary, but not the skills to program. Your thinking skills and your analyzing skills are important, but not the skills to program, because BigML can do that much faster and better than we can, because that's their core competence. Our competence as a bank is not building algorithms. So there are data scientists running around in the bank that have never, ever published a model, but they're busy for 3 years creating models. I was teaching for Ernst & Young, a smaller group than this, 25 young professionals. They were busy with large organizations making models. My first question was, who has a model in production? Nobody. Working 2 years on a model, nobody in production. That's the issue. Adding value from data science needs to have that endpoint, getting things into production. And production means in your real systems, data on a day-to-day business. This was, and then some challenges come. One of the challenges was last year. The Dutch bank, a regulator came at my management and said, we need to do something about anomaly detection because we do not trust that you have your monitoring okay so we need to see if you're doing the right things. So we started the first call. This is a week. These are days in a week. First call on senior manager was on Thursday night, Friday. Then I need to got my head around some data. I needed to evaluate 18 million customers and get some data of them. As you already saw, we do 10 million transactions a day. That counts up to approximately 3.8 billion transactions a year. And I had to have some ideas on anomalies in a year of data based on a peer group analysis in there. Okay, so I started that, and the data arrived at Wednesday morning very early. There was some panic at Saturday night. I was blazing, and I think I was chatting with Paul, something was something with scripts and stuff like that. But Monday I had my first results. And what are the results? The results were amazing. We had, I created such a nice workflow, just to split up the 18 million customers into two groups, private customers and corporate customers, and just do anomaly based on peer groups. The first one on a age category and an account type, and an SBI, that's a company type code or something like that. It's just saying something is retail or something is agricultural, stuff like that. We did some anomaly detection. We made anomaly detectors per peer group, then put them together, and then I created for the anomalies all above 60%, I created clusters on the anomaly score on the anomalies scores. I created clusters so I could explain to the analyst what the anomaly was about. But if you look at this is nice, it's technology, but you need to take care of how to form your teams and how to go about with the process to come to models, because it's not a waterfall model. It's a model that needs creativity, design thinking. You need some leadership that allows experimenting, because you cannot do from, okay, that's the other thing. I just make some documentation on how the system will work, and then I give it to IT, and IT will make it work. No, that's not the way it works anymore. I have data, and I need some ideation. So what problem am I going to solve? And what kind of people do I need? And it's an iterative, creative process. Everything AI promised us to free us up from the boring stuff and get creative. That's what it is. But you need to think on it how you design your departments to do this. And if you listen carefully, my perfect department would not be an IT department, but that's another thing. So this is already what we had, but this is important to have this in mind also, that you need something like that. You need a machine learning platform, you need an actuation platform, something you can actually run your models, and not without any ado. We need to put them in production as soon as we can. So this is a model, how to do ML in teams. This is the set you need to take into account. My 4 T's, that's technology. You need an AI ecosystem. You need research tools to place on top of that. You need trust, there's focus and mandate. You need to have the trust of your management that you can experiment and do the things you want to do. You have task, research, create, and operationalize. And you have a team that has diversity, power to execute, power to think, and ability to think differently. And those are the things you will need for it. So if you sum up the competences of people in machine learning, this will count up. And you will need a team, and the maximum team I would start off experimenting are these 3 things. People, somebody who knows something about AI, ML. That's handy, it comes in. A domain data expert. Somebody needs to tell you what the data means. where it is and how to get to it and how to format it. And you need a business domain expert, because without him, you cannot evaluate your model. You need to make sure it makes sense in a business context. And then data scientists, Superman. And for my department, I changed the name of the data scientist because it is way out. It's not what it's actually meant to be. And it's having the illusion that it's science. No? And what data scientists do is applying models to real life data to solve business problems. So look it up. I named my people in the team now decision engineers, because that's the thing we want to do. We want to engineer, and what do we want to engineer? The decisions that an organization makes, or that we have to make as an organization to be more effective, productive, compliance, less fraud, etc., etc., etc. That's where it's all about. And if you look up decision intelligence linked to decision engineering in Wikipedia, you find that it's all about data science, social science, decision theory, managerial science, best practice, decision making, and machine learning. Yeah, those things need to come together. It's not only a technical task, it's AI and machine learning is a business task. And how to do in execution, you have to do it into execution, and this is a little bit the thing we do with Reshield and Rabobank. This is Rabobank. These are the current projects. We do things on data drift. We have a problem in, is there new data coming in our monitoring systems that we do not know of? So we made, with BigML, a data drift detector. We are risk rating calibration. There are hundreds of people making credit models, but we now, with BigML, do with one click, we do a rating calibration if what they did is a little bit okay. And we, of course, do fraud. And you see we are at the upper part there, because we need 99.99% precision in that. These are the current projects we work on: fraud, AML, CDD, know your customer, credit risk, compliant auditing, data, sanctions, real estate. Our sanctions is interesting. We do as a bank, who knows sanctions, what the meaning of that is? Okay, if the UN or somebody says you cannot transfer money or US dollars to Cuba, you need to flag this as a bank and research that. We have, in a month, we have 90, and those systems only work on text descriptions and lists, and we have, in a month, 92,000 alerts, of which only 10 are true. So that's, and every alert takes a few minutes, so that is a huge amount of people working on that. We are busy reducing that to, I think, 2,000 a month. And then you see what BigML and machine learning can provide. We do real estate dynamic pricing. We do financing for real estate, and we are busy with modeling for dynamic pricing. And we have a model for privacy violations on our CRM account. We have more than 55 users, most non-IT staff. Number of organizations we created within BigML. For us, this is a perfect place to work together into organizations. And I just took some statistics from BigML. These were the last few tasks we did. 3,500 modeling tasks, 3,100 evaluation tasks. So we really use it, and for me, I'm now training an audit team with 16 people who never touched something real IT except Excel. They only use Excel to do their analysis, and now we train them in XML, in BigML, to put in the data, look at the quality of the data, and then do anomaly detection, and they have the 10 questions they have to ask. They can ask their auditee, and they are perfect. So there's a team that has there's almost no coding skills, but can work with, for a specific task, with BigML, and it's being a success. So, design and architecture first, to make things work. It's a business task, and you have to design your organization accordingly. Look at decision engineering as a task to be covered, so decision engineering. Start experimenting and keep experimenting. So not do only experimenting in the proof of concept, work with real data and do experimentations and involve as much business people as possible. And they are mostly very keen and knowledgeable about what needs to be happen. And educate and train staff and senior management. I sat with senior management, that's our CEO -1, for one day to talk about, to learn him how to use BigML. Why? Because he said, I want to know if I'm talking to a regulator what we are doing. And build the right team. Thank you.